For a tennis ball brand to be approved for tournament play by the United States Tennis Association, it must satisfy several specifications. One specification is that when the ball is dropped onto a concrete surface from a height of 100 inches, the ball must bounce upward at least 53 inches, but no more than 58 inches. When a tennis ball is dropped from rest and bounces continuously on a level, concrete surface, each rebound height of the ball is less than the previous height. In this project, you will analyze a bouncing tennis ball. You will find a mathematical model that defines the ball's rebound path and use an infinite series to calculate the total vertical distance traveled by the bouncing ball. You will use a data table and graphing to analyze the behavior. By doing some research on the USTA website, we were able to find the types of balls that were approved by the USTA officials.
We flew halfway across the world to retrieve an official USTA tennis ball.
We dropped the ball from the height of 100 inches and measured the maximum height of each bounce.
To find the function that fits the describing behavior, we used an exponential model. Our starting point was 100 inches, n equals the number of bounces, h equals maximum height, and we found the rate by looking at the ratio between the first and second trials and the second and third trials. From all this information, we came up with an equation of 100 times 0.55 to the power of n.
Using our handy-dandy TI Inspire, we were able to plot the data points on a graph and checked our equation to see if it matched the points.
Since the ball repeats a pattern on each bounce, we use a periodic mathematical function model that describes its repeating behavior. Since the ball starts at maximum point, we assumed that cosine would be involved when graphing the periodic function. We figured out that the period is 2, and from plugging in 2 in our equation to solve for b, we got b equals pi. The amplitude that we got was from the previous equation, 100 times 0.55 to the power of n. From all this information, the final function that we came up with was 100 times 0.55 to the power of n times cosine of pi times n. The function that we got that shows bounces above ground only is the absolute value of 100 times 0.55 to the power of n times cosine of pi times n. Using our handy-dandy TI Inspire once again, we were able to plot the data points on a graph and checked our equation again to see if it matched the points. A formula that includes an infinite geometric series can be used to calculate the total vertical distance traveled by the ball until it comes to rest. By adding a sigma notation to our previous periodic function, we were able to derive a formula that includes an infinite geometric series to find the total vertical distance traveled by the ball until it comes to rest. From our derived formula, we were able to find the total vertical distance traveled from the ball until at rest by plugging it into our calculator. In total, we got 344.4 inches of the total vertical distance traveled. A new brand of tennis ball is tested in the same manner. It was dropped from 100 inches, and after completing 5 bounces, the ball traveled a total vertical distance of 376 inches. USTA rebound limits are from 53 inches to 58 inches. Use the sum formula to decide if this ball will be approved by USTA.
Oh hey, we're here at Golden State. As an official NBA
Referee, I make sure the balls bounce from 51 to 56 inches when dropped from 6 feet. Hey!